Hi guys, welcome to Tutor Bedford. This is another video today and we're going to be looking at integration, and we'll be doing integration by differential equation. So one of the things that you could do in differential equation, and this is only be for the A-level maths. In pure maths we have other methods, on the further maths there are other methods of doing this. So today we're simply going to be looking at how to separate the variables. So suppose you have two functions, dy dx equals to some function of fx and gy. We could multiply both sides by dx and then divide both sides by gy. So now what we have is all the functions of y on the left hand side and f of x on the right hand side. Because it's dy and dx on the left hand and right hand, we could simply integrate both sides. That would solve that problem. So if we look at this equation here, we asked to find the general solution, so hence there's no boundary values given. So first thing we're going to do is simply multiply both sides by dx to get rid of the dx on this side, and then divide by tan y. So we have 1 over tan y, 1 plus x squared dy equal to x dx. And now we could simply just divide both sides by 1 plus x squared. So we have only the y on the left hand side and x on the right hand side. If we integrate both sides, so 1 over tan y dy equal to x over 1 plus x squared dx. So now if you rewrite this, 1 over tan y we know is actually equal to cot y. So we have cot y dy and x over 1 plus x squared dx. So now we're going to integrate both sides. And you could use a formula booklet for the cot y. You know, there's some standard integration that's given in the formula book, and that's one of them. So if we look at the formula book, we get that cot x equal to 1 over k ln sine kx. So in this case, our k is simply 1. So if I integrate cot y, I'll get ln sine y on the left hand side. And on the right hand side, if you recall from our previous video, the top is actually a derivative of the bottom with the adjustment of the 2. So if I put 2 at the top, I could simply just put half outside the integral. So that will give me half ln 1 plus x squared plus c. Now you obviously know why we have the c, because it's a constant of integration. And since we've got log everywhere, it would be nice to write c as in a log form. So since we're doing natural log, I could just write c as natural log k. So now, using laws of logs, one of the laws says that if you have a power, you can bring that down. So we should be able to do the opposite as well. So you can just simply take the half over. We use the additional law to tidy up the right hand side. And since we have natural log on both sides, if we take e on both sides, the natural log and the e's will cancel out. And then we have it, sine y is equal to k 1 plus x squared to the power of a half. Now, this is just a general solution since we don't know what the value of k is. And if we graph this, you can see the graph will depend on the value of k. So if k is equal to 0.1, it will look like this. If it's equal to 0.2, it will look like this, and so on. So if you have a graphical calculator, you guys could plot this and change the k value to see what the graph looks like. So now what we're going to do is actually look at a particular solution. So this time we're given boundary condition. So we know x is equal to 1 when y is equal to 4. So same as before, we're going to separate the variable. And we can integrate both sides after we separate the variable. Now left hand side is pretty straightforward. The top is actually derivative of the bottom, so it's going to be ln y minus 2. However, the right hand side, we have a bit of a problem because it's minus 3 over, and we've got two factors, 2x plus 1, x plus 2. So if you recall from my previous video, these can be solved using partial fraction. So if we split these up using partial fraction, you see it becomes this. And remember, partial fraction is also the first thing you would have done in A2 Pure Maths Chapter 1. So if you're not sure about this, refer back to the previous chapter. So now if we integrate, the left-hand side, as I said, it will be just ln y minus 2. On the right-hand side, again, the top is due to the bottom, so it's going to be ln x plus 2, minus, on the second one, again, the top is due to the bottom, so it's going to be ln 2x plus 1. And rather than writing c, as I said on the previous example, we could just write this as ln k. Now, using the laws of logs, we could tidy this up. Because when you're taking away, make sure you divide the 2, so it will be ln x plus 2 over 2x plus 1. And we could simply just use the log rule again, this time the additional one, which says you multiply them. And again, look, we have ln on left hand side and ln on right hand side. So we could simply just take e on both sides, and that will deal with the problem of ln. So we have y minus 2 equal to k x plus 2 over 2x plus 1. So now, if we just take the minus 2 over, and that would make y the subject. And we could substitute in the boundary condition, x equal to 1, y equals to 4. And if you tidy that up, we get k equals to 2. So now we know what k is. We could simply just substitute it in. So y would equal to 2x plus 2 over 2x plus 1 plus 2. So this one we say is a general solution, and this one we say is a particular solution, because we know what the value of k is. So I hope this helped and you understand the difference between a general solution and a particular solution. So now why don't you pause the video and have a look at this past exam question. Welcome back. So see if you got the following. And remember, the tan differentiation of tan x is sec squared. It's something that you have to know, especially if you're going to do further maths. It's something that comes up quite frequently. So we could do it by recognition here. The differentiating of tan x is sec squared. So integration of sec squared should be tan x. And notice that the end result here, we've got half y squared, 3 tan x minus 1. We haven't made the y the subject because it never asked us in the question to make y the subject. So you could just leave it like this. Or personally, I would prefer just to multiply everything by 2. So y squared would equal to 6 tan x minus 2. And then, if you did ask for y equal to some function, you could have just squared root the whole thing. So anyway, guys, I hope you enjoyed this video. Please subscribe to my channel, and until then, stay safe.